Okay, here we are on part 4 of the chapter review for chapter 3, and these problems will come from page 172. I think I'll get through about 1 through 57 on this video, at least that's my intent. Okay, so most of these questions are just going to test your ability to take the derivative, and so I'm going to go through these fairly quickly. I think this one's pretty easy. We just term by term, power rule. So 5x to the fourth minus 2 comes down, makes it 1/4 x plus 1/4. And on all these problems, let's just worry about the derivatives. We won't do much simplifying. Number 3, I have a product rule. I have 2 sine of x cosine of x, so I'm going to treat the 2 sine of x as the first function and cosine of x as the second function. So that simply makes the derivative. Derivative 2 sine x is going to be 2 cosine of x. Derivative of the first one times the second, which gives me another cosine of x, plus the first one times the derivative of the second one, which is negative cosine. Oh, no, it's not. It is negative sine of x. So I can't help myself. I have to simplify this. I get 2 cosine squared of x minus 2 sine squared of x, which is almost the Pythagorean identity, but it's a minus instead of a plus. Question 4, quotient rule. The derivative of the top, 2 times the bottom minus the top times the derivative of the bottom, just 2, bottom squared. The numerator in this would clean up pretty well, but we're going to, again, just leave it for now. Okay, so number 5 is not a product rule. Cosine is a function. 1 minus 2t is embedded inside of that function. We know it's not a product rule because just writing cosine doesn't mean anything. It has to be cosine of something. And so that makes it not a product rule. It is definitely a chain rule. 2 layers of a chain rule. The derivative of the outside function is going to be negative sine. And we don't change the inside function. And then we multiply by the derivative of the inside function, which should simply be negative 2. And again, easy to simplify, but we're going to leave it alone. Number 9 is just like number 5. We have ourselves a chain rule. In this case, we have 2 different variables, the r and the theta. But again, this is your dependent variable, and your theta is your independent variable. So we get r prime, or if you prefer, let's go dr d theta, just to mix it up a little bit. The derivative of secant is secant tangent, but let's be clear, it's a chain rule. The derivative of secant of something is secant of that same thing times tangent of the same thing. So the derivative of secant of x is secant x tangent x. The derivative of secant 1 plus 3 theta is, as you can see it. But that's just secant. Now I need to take the derivative of the inside function, which is 3. Number 10 is very similar to that. We're going to get r prime, or dr d theta. And I have this time 3 layers. I have a function squared. So that's 2 tangent to the first power, 3 minus theta squared. And so I've dealt with the 2. Now I got to deal with the tangent. The derivative of tangent is secant squared of 3 minus theta squared. So I've dealt with the tangent, and now I need to take the derivative of the inside function, which should just be negative 2 theta. Number 11, product rule and chain rule. So we have the first function and then we have the second function. So the derivative gives me 2x times the second cosecant of 5x plus the first function times the derivative of the second, the derivative of cosecant 5x. And again, for me, I just remember it by knowing what is the derivative of secant. Secant is secant tangent, so cosecant is going to be negative cosecant 5x. Looks like I'm going to run out of room. Cotangent 5x. So I've dealt with, so I'm doing the product rule. So the first one, x squared times the derivative of the second. So I've dealt with the cosecant. Now I have to take the derivative of 5, or 5x to get 5. Definitely kind of ugly, but that looks like the answer. Okay, number 12, not a product rule, because again, natural log has to be of something. So this is an embedded function. So the derivative of natural log is going to be 1 over whatever's inside. So I simply get 1 over the square root of x. But then I have to multiply by the derivative of the inside. I'm doing the chain rule. The derivative of x is going to be 1/2 x to the negative 1/2. Again, lots of cleaning could happen. I'm really testing you on the calculus right now. 13, another natural log question. So 1 over 1 plus e to the x times the derivative of the inside, and the derivative of 1 is 0, the derivative of e to the x is e to the x. Number 14 is a product rule. The first is 1 times the second is e to the negative x plus the first times the derivative of e to the negative x, which is technically a chain rule. So once again, x, the first function, times the derivative of e to the negative x is e to the negative x times negative 1. Because the derivative of negative x is negative 1. 15. The derivative of e to the power is the exact same thing. So e to the 1 plus natural log of x times, now the derivative of 1 plus natural log of x, 1 over x. Number 16, chain rule, not product rule. Derivative of the outside function, that's natural log, so that's going to be 1 over whatever's inside of natural log, times the derivative of what's inside. So the derivative of sine is cosine, which actually simplifies, I can't help myself, cosine over sine is cotangent of x. Not simplifying it is fine. Okay, now we're doing the log base a formula, and frankly I don't really have that one down quite as well, so I'm going to take my time here, make sure I'm right. The derivative of log base 5 of anything is just like natural log with one change. It's going to be 1 over what's inside of logarithm, but then it's also going to be down the bottom here times the natural log of 5. So that's the derivative of logarithm, and then the derivative of t minus 7 is just 1. So in this case our chain rule, while it does exist, it doesn't really provide us any change in the answer. The derivative of 8 to the negative t is a lot like e to the power. Okay, so we're going to follow a very similar rule, which says it's exactly the way the problem starts, but you also have yourself a natural log of 8. So that's the derivative of the 8 to the power. Now we need to take the derivative of negative t, which is negative 1. 23 we're skipping. We didn't do arctangent. That comes from the section we skipped. Okay, and now we move into finding the derivative, and in this case on number 35, we'll have to do it implicitly. So these problems we will need to simplify, and so I'll do the product rule, which gives me the derivative of x is 1 times the second one plus the first times the derivative of the second, so dy dx. Plus, so we're done with that term. Derivative of 2x is 2. The derivative of 3y is going to be 3 dy dx equals 0. Moving the values without to dy dx to the other side, and I'm going to just save myself a little room here. Factor out dy dx, and with what's left, I'm left with x plus 3 dy dx equals, so I subtracted the y over, and I subtracted the 2. And so I'm left with, again, leaving me with x dy dx plus 3 dy dx, which I then factored out dy dx to here, which gives me an answer I'm going to squeeze in right here of negative y minus 2 over x plus 3. Alright, I'm going to stop now because I'm at 12 minutes, and we'll pick up with problem 38 in the next video.